Now the polynomial equations y equal to b0 b1 x1 b2 x2 b3 x3 b4 x1 x2 b5 x2 x3 and b6 x1 x3. So y considered as the dark release at 10 hours, or y also considered as percentage dark entrapment efficiency, or in the other form like density, size, others. So y is only dependent on the individual factors, on response of the individual factors or influence of the individual factors, and also the interaction between the two factors. Okay, so therefore the one-way ANOVA will be performed by analyzing this data. So whatever we get from the practical consideration, we put the design expert software. There are different versions. So design expert software, and then we also perform the one-way ANOVA to find out the individual factor response on the y, and also the interaction of the individual factors, their response on the y value or dependent variables. Y also considered as a dark release at ANOVA or percentage dark entrapment efficiency, etc. So performing the one-way ANOVA by using the design expert software, here all the data are analyzed at 95% confidence level and less than 5% errors, or there should be the p value should be 0.05%. 0.05% p value. It indicates the 95% confidence level, and probability value for significance of the model should be less than 0.05%. So this is the polynomial equations. Now we get the corrected form of the polynomial equations. Now we get the corrected form of the polynomial equation. Here the individual response of the variables and their interactions, each value, as for example, there is the x2 and x3, interaction of the two factors x2 and x3. If after practical consideration we put the value of the design expert software at the 95% confidence level, and p value less than 0.05%. Now we have the p value, we get 0.07. So therefore this term should be considered as non-significant, because 0.05% greater than is the 0.05%. So p value should not be less than 0.05%. So this term considered as the non-significant. So after that non-significant term deleted from the original polynomial equations, we will get the corrected form of polynomial equations, and this equation generally reduced equations. After that, after getting the corrected form of the polynomial equations, the software also gives that several optimal formulas. As for example, now we take the x1. It's a polymer. I consider here. So its value 90 to 100 mg. Then it is provided by the software also gives the value or restricted zone of the x1 factors. That means this factors x1 should be restricted between the 90 mg to 100 mg. Another x2, its range also consider 80 to 90. The another factor x2, software gives the restricted zone or restricted area of this parameters is 80 mg to 90 mg. And now the another third factors, software also gives the zone 60 to 70. This is all the imaginary. That's for example I am telling this. So that means several numbers of the optimal formula software gives, and after that, as for example, the three factors x1, x2, x3. Suppose software gives the 90 mg to 100 mg. So we get the 95 mg for x1 value. Here also we get the value the x2 85 mg. Here also we take the value of the 60 70 and 65 mg. After choosing these three factors, we produce the against 8 formulations. Against 8 formulation, not 8 formulation, the 3 sets of the 8 formulation, but the n should be 3. The number of sets should be as a triplicate manner. So we produce the 8 sets, but into the triplicate manner, n equal to 3. After producing these sets, then we go for the practical considerations. Software also gives the predicted value, and actual value. Predicted value and actual value. Which predicted value? Now, this predicted value is the percentage drug release. And as for example, drug interment efficiency. So what we will get? The predicted value software provides say 80% drug release at 10 hours. 80% drug release at 10 hours and drug interment efficiency 90%. After choosing these factors. So after that, the software also gives the actual predicted value of the particular value like 85.1 mg, 86.1 mg. The range should be the 90 to 100. Okay, so after getting the particular range or particular amount of the x1, x3, x3, we produce the formulations. 8 formulations each and 8 number, the triplicate manner to produce the formulations. So therefore, the predicted value software gives 80% and drug interment efficiency 90%. After performing the experiments, we will get from the practical considerations if the actual value is difference of the whatever predicted the software 80% and if actual value should the difference should not be the greater than 5%. The difference should not be greater than the 5%. The difference should be less than 5% if occurred. So if it is greater than 5%, the predicted value and the actual value whatever you get from the practical consideration, so the model will be insignificant. But less than 5%, if the difference between the less than 5%, difference between the actual value and predicted value and actual value less than 5% difference, so model will be significant. Model will be significant. So we will get the optimized formulation by which we use the specific amount of the three factors. Then we produce the number of the formulation after practical considerations. If it is varies less than 5% of this value and also less than 5% of this value drug interment efficiency, so the model will be significant. So I repeat, the conventionally the pharmaceutical formulator researchers develop the different type of the products, or various kind of the products. But these methods, by ordering the one variable at a time, but this method is very much time consuming and lengthy method. By using the factorial design is a good tool. Factorial design is a useful tool, statistical tool, by which we can produce the different number of the product, and also it will be a less time consuming and less lengthy method. Thank you.